Indeed, this intricate interplay between the physical scattering of light, our own biological visual systems, and the cultural lenses through which we learn to perceive the world paints a far more nuanced picture than simply stating the sky is blue because of physics alone. The elegance of Rayleigh scattering gives us a crucial piece of the puzzle, explaining the prevalence of shorter wavelengths reaching our eyes, but it doesn't fully capture the subjective experience of gazing upwards. It highlights how much of our perceived reality is, in fact, a co-creation, a negotiation between the external world stimuli and our internal interpretive frameworks. Our biology sets the stage, determining the range of light we can detect, but it's our cognitive processes, shaped by learning and language, that truly color our world. To delve a little deeper into these cognitive aspects, exploring how the brain translates physical phenomena into conscious perception, I'm joined by Luxit, who has studied how we build our understanding of the environment. Luxit, welcome. When we consider the journey from photons striking the retina to the conscious thought, the sky is blue, how does the brain actually synthesize these disparate elements, the raw physics of light, the specific sensitivities of our cones, and those powerful learned associations we acquire throughout life, to arrive at that seemingly simple, almost universal conclusion?
Thank you, Ajahn. It's a truly fascinating orchestration within the brain. It's definitely not a passive recording process. Think of it more like constructing a narrative. The initial signals from the cone cells in the retina, responding differently to various wavelengths, travel along the optic nerve to the primary visual cortex at the back of the brain. Here, basic features like color, orientation, and movement are processed. But this is just the beginning. This raw data is then relayed to higher-level association areas. This is where the real interpretation happens. The brain draws upon vast networks of stored information. Our semantic memory, which holds facts like the sky is typically blue, and our episodic memory, containing recollections of specific instances of seeing blue skies, perhaps linked to feelings of warmth or openness. Crucially, the brain engages in what cognitive science often calls predictive processing. It's constantly generating hypotheses about the world based on past experience. So, when the visual system registers a strong signal in the shorter wavelength range coming from above, the brain's prediction is strongly weighted towards blue sky. This prediction is then compared against the incoming sensory data. Unless there's a significant mismatch, like seeing a fiery sunset, the prediction holds and we consciously perceive blue. Language plays a huge role here too. Having a specific word, blue, helps create a distinct category. Our brains become very efficient at slotting sensory input into these learned categories. This categorical perception means we might perceive a range of slightly different wavelengths all as blue, potentially glossing over subtle violet or greenish tints that are physically present, simply because the blue category is so strongly primed by context and language when we look up.
That concept of categorical perception is quite illuminating, Luxit. It suggests a kind of cognitive efficiency, doesn't it? The brain simplifies the infinite gradations of the physical world into manageable labels, allowing us to navigate and communicate effectively. Yet, as you imply, this efficiency might come at the cost of perceptual richness. By readily applying the blue label, reinforced by language and expectation, we might indeed become less sensitive to the actual subtle variations, the slight deepening of the azure towards the zenith, or the paler tones near the horizon, or how haze and humidity subtly alter the light's transmission and scattering. It makes one ponder those cultural differences mentioned earlier. Perhaps societies with different linguistic categories for colors, or those living in environments with dramatically different atmospheric conditions, genuinely construct a different perceptual reality of the sky, less constrained by the simple blue category that seems so dominant in many Western cultures. It also brings to mind how atmospheric phenomena, dust, pollution, water vapor levels, objectively change the light reaching us. Our brains must register these changes at some level, even if our conscious report remains "the sky is blue." Perhaps it contributes to a feeling, an intuition about the air quality or the weather, even if we don't explicitly decode the subtle shift in hue.